this lesson, I'm going to talk more about solving linear equations. Then Steve's going to talk about solution sets, and Anne is going to introduce interval notation. So in particular, I'm going to review the properties of equality. I'm going to look at some equations that involve simplification, some equations containing fractions, and then I'm going to end by giving a general strategy for solving linear equations. So let's start by reviewing the properties of equality. Some of the properties of equality that we've looked at so far are, first, the reflexive property, which just says that an expression is always equal to itself. A is equal to A. The symmetric property of equality, which says A is equal to B if and only if B is equal to A. This is the property that allows us to switch the left and right-hand sides of an equation. And the transitive property of equality, which says if A equals B and B equals C, then A equals C. We use this when we're simplifying expressions. A couple of properties of equality for solving linear equations that we've looked at tell us, one, the same real number or algebraic expression may be added to both sides of an equation without changing the solution. This is called the addition property of equality. If A equals B, then A plus C equals B plus C. The second one says both sides of an equation may be multiplied by the same non-zero real number without changing the solution. The multiplication property of equality says A equals B if and only if AC equals BC and C does not equal 0. So let's solve some equations that involve simplification. Let's say I want to solve 2x minus 8x plus 35 equals 5 minus 3x. The first thing I'm going to do in solving this equation is simplify the left-hand side. I have like terms 2x and negative 8x. 2x minus 8x is negative 6x. So I have negative 6x plus 35 equals 5 minus 3x. Now I have variable terms on both sides of the equation and constant terms on both sides of the equation. I think I'll move my variable terms to the right-hand side of the equation and my constant terms to the left-hand side of the equation. It doesn't make any difference. I can move to either side. I'm just choosing to move my variable terms to the right-hand side. To move my variable terms to the right-hand side of the equation, I'm going to add 6x to both sides of this equation. So negative 6x plus 35 plus 6x equals 5 minus 3x plus 6x. Simplifying, I'm left with 35 on the left-hand side and 5 plus 3x on the right-hand side. Now to move my constants to the left-hand side of the equation, I'm going to subtract 5 from both sides of the equation. So 35 minus 5 equals 5 plus 3x minus 5. Simplifying, I have 30 on the left-hand side equals 3x on the right-hand side. To isolate x, I'll divide both sides of this equation by 3. So 30 divided by 3 equals 3x divided by 3. Simplifying, I have 10 equals x. This is equivalent to saying x equals 10. So my proposed solution is 10. Whenever you're asked to solve an equation, you always need to check your proposed solution in the original equation and write your answer in a complete English sentence. Even if the directions only say solve the equation, you need to always remember to check your solution and write your answer in a complete sentence. So our proposed solution was 10. Let's check that. If x equals 10, well, looking at the left-hand side of the equation, 2x minus 8x plus 35 would equal 2 times 10 minus 8 times 10 plus 35. Notice that I substituted the value 10 into the original form of the left-hand side of the equation, not my simplified form. I might have made an algebra error or an arithmetic error in my simplification. So 2 times 10 is 20, minus 8 times 10 is 80, plus 35. 20 minus 80 is negative 60. Negative 60 plus 35 is negative 25. Now I need to also see what happens when we substitute 10 for x on the right-hand side of the equation. So if x equals 10, then 5 minus 3x would equal 5 minus 3 times 10, which is 5 minus 30, which is negative 25. My proposed solution checks because both sides of the equation evaluate to negative 25 when x equals 10. So now I can state my conclusion. The solution is 10. Now let's say I want to solve 7 times the quantity 3z minus 2 plus 5 equals 6 times the quantity 2z minus 1 plus 24. The first thing I would do to simplify this equation is distribute the 7 through the parentheses on the left-hand side and distribute the 6 through the parentheses on the right-hand side. 7 times 3z is 21z, minus 7 times 2 is 14, plus 5 equals, on the right-hand side, 6 times 2z is 12z, minus 6 times 1 is 6, plus 24. Now I have some like terms I can combine. On the left-hand side, my constants, negative 14 and positive 5, can be combined. So the left-hand side simplifies to 21z minus 9. The right-hand side also has some constants I can combine. The right-hand side simplifies to 12z plus 18. This time I think I'm going to isolate my variable terms on the left-hand side of the equation and move my constant terms to the right-hand side of the equation. So I'm going to start by subtracting 12z from both sides of this equation. So 21z minus 9 minus 12z equals 12z plus 18 minus 12z. Simplifying, 21z minus 12z is 9z. So 9z minus 9 equals, on the right-hand side, I just have 18 left. Now I'm going to move my constants to the right-hand side. So I'm going to add 9 to both sides of this equation. Simplifying, I'm left with 9z on the left and 27 on the right. To isolate z, I need to divide both sides of this equation by 9. Simplifying, I'm left with the equivalent equation, z equals 3, which has the obvious solution, 3. Now I need to remember to check my proposed solution. So if z equals 3, now I want to check this proposed solution in the original equation. So I want to look at the right-hand side and the left-hand side separately in the form that they're given. Starting with the left-hand side, if z equals 3, then 7 times the quantity 3z minus 2 plus 5 would equal 7 times the quantity 3 times 3 minus 2 plus 5. 3 times 3 is 9, and when we subtract 2, we have 7. So 7 times 7 plus 5. That's 49 plus 5, which is 54. I also need to check the right-hand side. So if z equals 3, then 6 times the quantity 2z minus 1 plus 24 would equal 6 times the quantity 2 times 3 minus 1 plus 24. 2 times 3 is 6, and when we subtract 1, we're left with 5. So 6 times 5 plus 24. 6 times 5 is 30. When we add 24, we get 54. So my solution checks. Both the left-hand side and right-hand side of this equation evaluate to 54 when z is 3. So all that is left is to state my conclusion, which is the solution is 3. So now let's solve this problem given in words. I'm asked to write an equation, then solve and check it. I'm told the sum of twice a number and 7 is equal to the sum of the number and 6, and I'm asked to find the number. To save myself a little bit of space, I've just taken that key sentence. The sum of twice a number and 7 is equal to the sum of the number and 6. And I know we need to find the number. So I have an unknown here. What is that number? So I need to define a variable. So I'm going to let n represent the number. Then I need to write the equation that I'm going to solve. I'm told the sum keys me into addition, of twice a number and 7. Twice a number means 2 times the number. So 2 times n is what I'm calling the number, plus, because we're looking at a sum, 7, is equal to the sum of the number and 6. So is equal to another sum, addition again, the sum of the number and 6. So n plus 6. Now that I have my equation, I need to solve it. I have variables on both sides. I have constants on both sides. I'm going to move my variable terms to the left-hand side and my constant terms to the right-hand side. So I'm going to start by subtracting n from both sides of this equation. This simplifies to n plus 7 on the left equals 6 on the right. Now to move my constants to the right-hand side, I'm going to subtract 7 from both sides of the equation. Simplifying, I have n equals -1. Now to check the solution, I want to go back to the wording of the problem and make sure that the solution makes sense with the wording of the problem. I'm told the sum of twice a number and 7. So the sum of 2 times a number and 7. So if I take 2 times my number and add 7, that's -2 plus 7, which is 5. And this is supposed to be equal to the sum of the number and 6. So if my number is -1, excuse me, and I add 6, well, that's also 5. So it looks like this makes sense in the wording of the problem. So now that I've checked my solution against the wording of the problem, I'm going to go ahead and state my conclusion. Now I was asked to find the number. So I'm going to write for my conclusion, the number is -1. Now let's look at some equations containing fractions. When we're solving equations that have fractions, then the solution process is usually less taxing if you first eliminate the fractions from the equation. I want to look at a strategy for solving equations that have fractions. My first step is going to be to determine the least common multiple of all of the denominators that occur in the equation. Then I'm going to multiply both sides of the equation by the least common multiple found in step 1. Then I'm going to simplify both sides of the equation. Remember to use the distributive property on sides of the equation that contain 2 or more terms. If I've chosen the correct least common multiple and made no mistakes, then the fractions have now been eliminated from the equation. Go ahead and solve this equivalent equation, which contains no fractions. So that sounded like a lot of steps. Let's try it out with an example. So this equation has the fraction 7/5. Notice this time I'm asked to find the solution to 3x plus 4 equals 7/5. This is no different than being asked to solve 3x plus 4 equals 7/5. The problems and directions are sometimes going to be worded differently. You need to recognize that finding the solution to an equation is the same as solving an equation. So I want to eliminate fractions as my first step. My only fraction, as I said, is 7/5. The denominator is 5. I'm going to multiply both sides of this equation by 5. So 5 times the quantity, 3x plus 4, equals 5 times 7/5. I need to distribute the 5 through the parentheses on the left-hand side. 5 times 3x is 15x, plus 5 times 4 is 20. On the right-hand side, 5 divided by 5 is 1, so I'm just left with 7. The fractions are now cleared, and I can go ahead and solve the equation. I have just one variable term. I'm going to go ahead and leave that on the left, move my constants to the right, by subtracting 20 from both sides of this equation. Simplifying, I have 15x equals negative 13. Now if I divide both sides of this equation by 15, I can isolate x. So 15x divided by 15 equals negative 13 divided by 15. So x equals the fraction negative 13/15. Notice that I cleared fractions right away and avoided fractional arithmetic in the solution process, but there's no way of avoiding fractions for answers. I want to now take my equivalent equation, x equals negative 13/15, with a solution of negative 13/15, and check this. So if x equals negative 13/15, then 3x plus 4 would equal 3 times negative 13/15 plus 4. So I have 3 times negative 13 in the numerator. I'm going to write 15 as 3 times 5. And I'm still adding 4. 3 divided by 3 is 1. So I have negative 13/5 plus 4. Thinking ahead that I'm going to be doing fractional arithmetic here, I'm going to write 4 as 4 over 1. And I'm going to multiply this by 5 over 5 to build a common denominator. So I have negative 13 plus 20 over a common denominator of 5. And this is 7/5, which is good. This is what I wanted. The right-hand side of the equation is 7/5. The left-hand side evaluates to 7/5 when x equals negative 13/5. So my solution checks, and I can write it out. The solution is negative 13/15. Here's another problem with fractions. 3y over 4 minus 2/3 equals 7/12. Now I have 3 different denominators, 4, 3, and 12. I want to find the least common multiple of these denominators. Well, since 4 and 3 both divide evenly into 12, 12 is my least common multiple. So I'm going to multiply both sides of this equation by 12. So 12 times 3y over 4 minus 2/3 equals 12 times 7/12. So I need to distribute this 12. 12 times 3y over 4 minus 12 times 2/3 equals, well, on the right-hand side, 12 divided by 12 is 1, so I'm left with 7. Now I'm going to do a little bit of arithmetic in my head here. 4 goes into 12 3 times. 3 times 3y is 9y. Minus 3 goes into 12 4 times. 4 times 2 is 8. So now my equivalent equation, which contains no fractions, is 9y minus 8 equals 7. I want to isolate 9y on the left-hand side, which I can do by adding 8 to both sides of this equation. So 9y minus 8 plus 8 equals 7 plus 8. Simplifying, I have 9y equals 15. And I can isolate y by dividing both sides of this equation by 15. So I have y equals 15/9, but I can reduce that. 3 goes into 15 5 times, 3 goes into 9 3 times. So this reduces to y equals 5/3. Now I want to check my proposed solution of 5/3. So if y equals 5/3, then my variable expression, 3y over 4, notice I'm writing this as 3/4 y. I'm thinking ahead a little bit here. I'm going to be doing arithmetic with fractions. I'm going to be multiplying fractions. Y is the fraction 5/3. 3y over 4 just means I have a term with a variable of y and a coefficient of 3/4. That's how I've rewritten it. So I have 3/4 y minus 2/3 would be 3/4 times 5/3 minus 2/3. 3 goes into 3 one time, so my first term simplifies to 5/4, and I'm subtracting 2/3. Now I need a common denominator to subtract. 3 and 4 have a least common multiple of 12, so I'm going to multiply 5/4 by 3 over 3, and I'm going to multiply 2/3 by 4 over 4. So I have 15 minus 8 over a common denominator of 12. And that is 7/12, which is good. The right-hand side of the equation is 7/12. The left-hand side evaluates to 7/12 when y equals 5/3. So the solution is 5/3. Here's another equation involving fractions. 2x minus 2x over 7 equals x over 2 plus 17 over 2. Now my denominators are 7, 2, and another 2. 7 and 2 are both prime numbers, so their least common multiple is just going to be the product of 7 and 2, which is 14. So I'm going to multiply both sides of this equation by 14. 14 times 2x minus 2x over 7 equals 14 times x over 2 plus 17 over 2. 14 times 2x is 28x minus 14 times 2x over 7. I also need to distribute the 14 on the right-hand side of the equation. So I have 14 times x over 2 plus 14 times 17 over 2. Notice I'm writing out the distributive property on the terms that involve fractions, so I make sure I don't make any mistakes in my fractional arithmetic. So I have 28x minus, I'm going to do a little bit of arithmetic in my head here. 7 goes into 14 two times. 2 times 2x is 4x. On the right-hand side, 2 goes into 14 7 times. So I have 7 times x, which is 7x, plus 2 goes into 14 7 times. So I have 7 times 17, which is 70 and 49, 119. Now I have like terms on the left. 28x minus 4x is 24x. So 24x equals 7x plus 119. I want to isolate my variable terms on the left-hand side, so I'm going to subtract 7x from both sides of this equation. 24x minus 7x equals 7x plus 119 minus 7x. So this is 17x equals 119. Now if I divide both sides of this equation by 17, a little bit hard to read. That's supposed to be 119 divided by 17 on the right, which I know is 7. So I have an equivalent equation, x equals 7, which has an obvious solution of 7. Let's check this proposed solution of 7. If x equals 7, then on the right, or on the left-hand side, 2x minus 2x over 7 would be 2 times 7 minus 2 times 7 over 7. Notice I didn't rewrite 2x over 7 as 2/7 x. I could have, but it really didn't make any difference here since my proposed solution was an integer 7. I can just go ahead and multiply 2 times 7 in the numerator here. That's pretty easy. So I have 14 minus 14 sevenths, which is 14 minus 2, that's 12. So what about the right-hand side? If x is equal to 7, then x over 2 plus 17 halves would be 7 over 2 plus 17 halves, which is 24 over 2, which is 12. So both sides of this equation evaluate to 12 when x is equal to 7. So I know the solution is 7. Let's try solving this equation by clearing fractions. I have x over 2 plus 13 equals negative 22. My only fraction is x over 2. So I'm going to multiply both sides of this equation by that denominator, 2. So 2 times the quantity x over 2 plus 13 equals 2 times negative 22. 2 times x over 2 is just x, plus 2 times 13 is 26. 2 times negative 22 is negative 44. Now to isolate x, I'll subtract 26 from both sides of the equation. X plus 26 minus 26 equals negative 44 minus 26. Simplifying, I have x equals negative 70. So now I want to check my proposed solution. If x equals negative 70, then x over 2 plus 13 would be negative 70 over 2 plus 13, which is negative 35 plus 13, which is negative 22, same as the right-hand side. So this checks. So I can say the solution is negative 70. Now let's look at the same equation and let's try solving it without clearing fractions first. So again, starting with x over 2 plus 13 equals negative 22. If I ignore the fact that I have a fraction x over 2 and I just try to isolate that variable term, I'm going to move my constant terms to the right-hand side. I can do that by subtracting 13 from both sides of the equation. That leaves me with x over 2 equals negative 35. Now to isolate x, I can multiply both sides of this equation by 2. And that gives me x equals negative 70. That's what I just checked. When x was negative 70, my proposed solution checked, and I said, this worked. The solution is negative 70. Doing this problem without clearing fractions first wasn't really any more taxing. Well, let's look at why. I want to look at some of the equations that I've already solved and show that if I hadn't cleared the fractions first, my first step would have required fraction arithmetic. So I solved 3x plus 4 equals 7/5. If I had tried to solve this without clearing fractions first, I would have started by moving my constant 4 to the right-hand side. I would have had to subtract 4 from 7/5. I would have had to build a common denominator. That's fraction arithmetic. I also solved 3y over 4 minus 2/3 equals 7/12. Same thing here. If I hadn't cleared fractions first, I would have added 2/3 to both sides of this equation. I would have had to add 7/12 and 2/3, more fraction arithmetic. I also solved the equation 2x minus 2x over 7 equals x over 2 plus 17 halves. Now this equation, if I hadn't cleared fractions first, has a simplification on the left-hand side. I would have had to subtract 2x over 7 from 2x, more fraction arithmetic. Well, the problem that I just did in two different ways doesn't involve any fraction arithmetic if I don't clear the fractions first. When I solved this the second way, without clearing fractions first, all I had to do was subtract 13 from negative 22. Not difficult, not any more taxing than the other way around. Now I want to look at a strategy for solving linear equations. Our first step, if we have fractions, is going to be to clear the fractions by multiplying each side of the equation by the least common multiple of all of the denominators. Second, we'll simplify each side of the equation. Third, collect all variable terms on one side of the equation and all constant terms on the other side of the equation. Then we'll isolate the variable and solve. And we're not going to forget, always check the proposed solution in the original equation and state your conclusion in a complete English sentence. Now I'm going to turn this over to Steve, who's going to talk about solution sets.